In this video, we're going to see how to solve definite integrals in your head. Stay tuned. Hi, this is Ash with Math Hero Academy, bringing you a very interesting puzzle that you are expected to solve in your head. We are going to integrate sine theta divided by sine theta plus cosine theta between 0 to pi divided by 2. And there are quite a few methods to evaluate this integral using pen and paper, but given the special properties of definite integrals, we're going to solve this problem in a quick minute. So let's get started. Now to integrate this function, we're going to use a specific rule called the King's rule, and this is what the rule says. If you're integrating from a to b, if you're integrating f of x dx, you can rewrite this as a to b f of b plus a minus x dx. And this is a very useful property that we're going to use right now. Remember, the function remains the same, just the argument, the thing inside, becomes b plus a minus x, and the limits are the same. Let's try to prove this real quick. What we can do is we can substitute u to be equal to a plus b. Let's write it as b plus a, just to be conforming to this formula here. U is equal to b plus a minus x. That's going to be your u substitution, and let's substitute it inside this formula. So this a to b integral is going to be f of x, which is, now x is going to go to the left hand side and u is going to come to the right hand side, and we can write this as b plus a minus u, just substituting u in place of x here. And then the dx, right over here, we can differentiate this function. We get du is equal to negative x. That's the differential form of this equation. So dx will be negative du. So we write down du over here and put a negative sign. And now let's calculate the limits of integration, because they're going to change. We are now integrating with respect to u. So when x was equal to a, what would be the value of u? So u is equal to, using this formula, b plus a minus a, and these two a's cancel out, and so you get a b over here. So when x was equal to a, the u lower bound for this integral is equal to b. Similarly, let's calculate what the upper bound will be when x is equal to b, and once again we plug in b plus a minus x, this formula right over here, and when we plug in b is equal to x here, we're going to get a b over here, and this b cancels out, and so we get a at the top. Now interestingly, you have a negative sign and you're integrating from b to a. We know that we can reverse these two limits by removing the negative sign. So negative integral from b to a is equal to the positive integral from a to b. So let's rewrite that. So we cancel out this negative part and we change the order of integration right from a to b. And now we are almost done. Let's actually also erase these calculations here to make it more clear. And now we've got the integral of f of b plus a minus u du to be a to b. And remember, u is just a dummy variable here. The answer is not going to be in terms of u. You're going to calculate whatever your answer is, and then you're going to have a definite integral. You're going to plug in b and a inside the integration answer. So it doesn't really depend if you're integrating with u or you're integrating with respect to y. In this case, we can also plug in actually just the x variable. So let's, instead of u or y, let's make it x. So instead of y, we're gonna make it an x over here. And similarly, instead of y, we're gonna make it an x over here. So we've got x and x here, and this is exactly what we set out to prove. Integral of a to b f of x dx is equal to integral of a to b f of b plus a, that is the upper bound plus the lower bound, minus x dx. Remember, there's no positive or negative here, just the thing inside these brackets changes. And that's exactly what we're going to use to simply calculate this function. We've got integral of sine theta divided by sine theta plus cosine theta from 0 to pi divided by 2. And now we are just going to use this rule called the King's rule, and we're just going to write down 0 to pi divided by 2 sine of, remember here we've got 0 to be equal to a and pi by 2 to be equal to b. So we're going to write down b plus a minus x. So we're just going to write down pi by 2 plus 0, we can ignore the 0, minus x, or in this case it's theta, and then we just write down the d theta here. And then in the denominator, we're going to write down similarly sine of pi by 2 minus theta plus cosine of pi by 2 minus theta. Yeah, I'll just erase this part out for now just to make things clearer. And here we use trigonometric identities now. Remember, the pi by 2 minus theta is just the complementary angle. So you've got a right angle triangle here. If this were equal to theta and the sine of, we're taking sine of theta, and here this angle is actually going to be equal to pi by 2 minus theta. Of course, this is a right angle triangle, and so sine of pi by 2 minus theta, which is sine of this angle, is equal to the cosine of theta. So we can just write down cosine of theta in the numerator, and in the denominator, similarly, sine of pi by 2 minus theta is the same thing at the top. You've got cosine of theta, and here cosine of pi by 2 minus theta, which is, if this were pi by 2 minus theta, and the cosine of this angle would be exactly equal to the sine of this angle. So we can write down sine of theta right over here. We copy down this d theta right from here, and we just copy down these integration limits. And now we've got this integral from 0 to pi by 2 of sine theta divided by sine theta plus cosine theta d theta is equal to, using the King's rule, using this idea here, is equal to 0 to pi by 2 of cosine theta divided by cosine theta plus sine theta d theta. Now here's the hint for you. Pause the video for a few seconds and see if you can now solve this integration in your head. Alright, hopefully you were able to solve at least a part of this problem. What you can do is assign this value to be equal to I, and that's the standard way to do it. You just assign this to be equal to I, and this is also equal to I. So let's add these two together. So you're going to get 2I, because you're just adding these two, is equal to the integral of this function plus the integral of this function. So we just add these two. So we're going to get 0 to pi divided by 2 of sine theta divided by sine theta plus cosine theta, which is just the first function, plus cosine theta divided by sine theta plus cosine theta. And of course we're adding these, so we can just combine this. We can put a bracket around and put a d theta here. And now it should stand out to you what can be done next. Because we've got the same denominators, we can just combine these numerators. We've got sine theta plus cosine theta in the denominator, and then we get a sine theta plus cosine theta in the numerator as well. So we can just, in place of all of this, we can just write this to be equal to 0 to pi by 2 of sine theta plus cosine theta divided by sine theta plus cosine theta d theta, and then the numerator and denominator cancels out, and so all you're left with is the integral of 0 to pi divided by 2 of d theta, and we know the integral of d theta is theta, and so this integral is equal to pi divided by 2, and so 2I is equal to pi divided by 2, which means I is equal to pi divided by 4. Alright, so here's the challenge problem for you. you've got the integral of 0 to pi of cosine of theta squared d theta. You know you can use the double angle formula. You've got cosine of 2 theta is equal to 2 cosine squared theta minus 1, and then you can manipulate it and do it. It's a little bit boring to do that. Now that you know the King's rule, I invite you to find out this answer just using your head, not using any pen and paper. Just plug in this value inside and you're going to get another expression and see if you can solve this. Here's the hint for you. You can break this expression as 0 to pi divided by 2 plus pi divided by 2 up to pi, and first try to evaluate this part using the King's rule, and then this part will be very symmetric and then you can evaluate this. But to evaluate this part, you can easily do it in your head. So good luck with solving this problem, and post your answers or hints in the comment section below so that all of us can see that you're able to solve this problem in your head. And don't forget to like and subscribe to this channel, and feel free to forward this video to your friends. Talk to you very soon in the next video.